example 2. And in example 2, we have two functions. We have a cosine function and a linear function. And so given f of x equals cos of pi over 2x and g of x equals x, determine the equations of h of x, which will set the sum of the two functions, and k of x, which will set the difference between the two functions. So let's start by doing that. So let's take a look at h of x. So h of x looks at the sum of the two functions, and if I look at the sum of the two functions, I would essentially add cos of pi over 2x plus x, and that's essentially all I can do for h of x. The only operation I can do is add them together, and you'll notice that because they are not like terms, I can't combine it any further. Okay, and then let's look at k of x. And that looks at the difference between the two functions. So I'm going to look at cos of pi over 2x minus just x. So there's our sum function and our difference function. Okay, adding f of x and g of x and subtracting f of x with g of x. Okay, then you're asked to look at the domains of h of x and k of x. Now, it doesn't matter whether you're adding the two functions or subtracting the two functions. The domain is going to be exactly the same. And so what you want to think about is what the domain of the original functions were to figure out where they overlap, so you can come up with the domain of the combined functions. So what I want to think about, and again, there's a couple of different ways of doing this. You can either look at the domains along a number line, or you can look at what the domain is in the set notation that we've looked at all along. And so if I look at the domain of f of x, I know that the domain of f of x is all real numbers because we're looking at a trig function that continues infinitely from the left to the right. And if I look at the domain of g of x, this is just a linear function, and again, there are no restrictions on the domain. It exists for all real numbers. Now, the values of x where the domains overlap, you'll notice that because both the domains are all real numbers, the domains of the combined functions, h of x and k of x, will also be all real numbers. So the domain for h of x and k of x will also be x is an element of all real numbers. So the goal is to see where they overlap. If they overlap everywhere, then that's perfect. They overlap everywhere. Okay, in part C, use the graphs of f of x and g of x to sketch the graphs of h of x and k of x. So we have two different sketches here, and both of these graphs have the original functions for f of x and g of x drawn. And so I think the reason why we have two different graphs here is so that we can draw h of x in one of them, which is the sum function, and k of x in the second one, which is the difference function. So let's start by looking at the sum. And so this is going to be the graph of h of x that we eventually draw. And if we remember from the original question, h of x represents the sum of the two functions. So ideally what I'm going to look for are some pretty decent values of y for particular values of x. So let's start with x equal to negative 6. And our scales vertically go by 2s. So halfway in between I know goes by 1. Okay? And so if I look at x equal to negative 6, for f of x, the blue graph, I have x equal to negative 1. And for g of x, which is a linear function, I have x equal to negative 6. Now if I add these two numbers together, I get negative 6 plus negative 1 plus negative 6, which is negative 7. So if I roughly draw that point, if I add those two values together, I get a point that's below the actual grid that I'm given. Okay, let's look at the next one. I have, for the value of x equal to negative 5, in the first function I have y equal to 0, and in the second function I have y equal to negative 5. 0 plus negative 5 gives me negative 5, so this point happens to overlap the graph there. Let's look at the next point, and so I have positive 1 plus negative 4, so 1 plus negative 4 is negative 3, so this point here would be at negative 3 if I combine the two functions. And if I keep going from there, so 0 plus negative 3 is negative 3. And I'll keep going from there. Negative 1 plus negative 2 is negative 3. line there or something. Next point is at 0 for y here, negative 1 for y here. 0 plus negative 1 is negative 1. Okay, at x equal to 0, we have 0 plus 1, which is equal to 1, so it overlaps the trig function there. And I'll keep going. Negative 1 plus 2 is 1. 0 plus 3 is 2. Oops, 0 plus 3 is 3. They say I'm a math teacher. 1 plus 4 is 5. 0 plus 5 is 5. And negative 1 plus 6 is 5 as well. And so it looks kind of weird here. I feel like the graph should be doing something like this. But I don't really know what's going on. Something like that. I don't really know. The only reason why I'm drawing curves going up and down is because remember that when you're combining functions and there was some local maximums and local minimums, then the combined function should also have local maximums and minimums as well. And so the reason why this graph looks like it's going up and down, but also going up and to the right, is because when you combine the cosine function with the linear function, you'll notice that the functions are still increasing, but they're going up and down because the cosine function is going up and down as well. Okay, so it's kind of neat. You still have your local maximums and your local minimums, and the reason for that is because one of your functions had local maximums and minimums as well. And you'll notice that the domain is all real numbers. The graph continues to the left and to the right. Okay, so that's some interesting things to look at. Okay, if we graph k of x is a little bit different, so I need to pay attention to what I do a little bit more in this case. K of x looks at f of x minus g of x. So I need to subtract the red graph from the blue graph. Okay, so now I have to be a little bit more careful with what I do. This is going to be negative 1 minus negative 6. So negative 1 minus negative 6 gives me positive 5. So this graph, first point is going to be up here. Okay, again, blue minus red, right? Cosine minus linear. So 0 minus negative 5 gives me positive 5. 1 minus negative 4 gives me positive 5. 0 minus negative 3 gives me positive 3. Negative 1 minus negative 2 gives me positive 1. 0 minus negative 1 gives me positive 1. 1 minus 0 is 1. 0 minus 1 is negative 1. So now we're moving downward. And then negative 1 minus 2 is negative 3. Moving downwards again. 0 minus 3 is negative 3. 1 minus 4 is negative 3. 0 minus 5 is negative 5. And negative 1 minus negative 1 minus 6 is negative 7. So that's down here again. So it's sort of the opposite of what we had in the previous graph. And if I sort of sketch what I think it might look like, maybe it's something like this. Comes downward, goes up, and then downward, up. Something like that maybe. So I'm not sure what it looks like exactly, but here is the actual graph of what h of x and k of x should look like. So you'll notice that this graph goes up and to the right. We still have local maximums and minimums. And this one comes down and to the right. Again, we still have local maximums and minimums. So we're pretty close, but that's the way it should look like. Okay? The only reason why this one looks like it's coming down and to the right is because you subtracted a linear function that had higher values and lower values of y at the two ends. And so it actually flips the graph because now these values become negative. Okay? Cosine minus linear ended up giving you a graph that comes down and to the right.